polar form of a complex number. So we need to discuss how to convert a complex number to polar form. Say, suppose we have a complex number x plus iy. So we consider x equal to r cos theta, y equal to r sin theta. Then z can be expressed as r x cos theta plus r cos theta plus I r sin theta, or you can write cos theta plus I sin theta. So this is the polar form of a complex number. Now when we discuss polar form of a complex number, we have two quantities. One is r, one is theta related with x and y. So r is called modulus of z, and theta is called argument of z, or sometimes we call amplitude of z. Now, given a complex number, you will get only one values of r, only one, which is 0, maybe positive, because when we take this one, relation between x and y and r, we have r equal to root over x square plus y square. So r is the actual distance between the, if we represent the complex number in polar, in Argand plane, suppose this is the z, which is like this is x, this is y, and this distance O to say P position, OP will be the values of r. Since it is a distance between, this is nothing but distance between 0, 0 and xy by coordinate geometry. So we know that by coordinate geometry we know that xy and 0, 0. Distance between these 2 points is nothing but this one. This is the distance. So distance is always positive. So that is why we call r is always positive. Maybe 0, because if x and y both are 0, then r will be 0. So r is a non-negative number, non-negative real number. We call it non-negative, and we denote it by modulus of z. Now, what about theta? If we plot a complex number in Argand plane, this angular measure, which I call theta, this is the argument of z. So if we take different position of z, you will get different values of theta. So theta lies between 0 to twice pi. 0 to twice pi. Theta lies between 0 to twice pi. Within these two, we have the values of theta. Now, when we call x equal to r cos theta and y equal to r sin theta, so you see theta may be different, because we know that when we take theta equal to 0, say twice pi, difference between two values twice pi, like that, then we see cos theta will be 0 means 1 in twice pi, this is also 1 on this. Sin theta is 0, 0, 0 to 1. So different angular values, we take theta 0, twice pi, 4 pi, etc. We have different, we have same values of cos theta and sin theta. Because of that, we represent a complex number which is x plus iy infinite ways. When we take say x equal to r is fixed, for a complex number r is fixed, r cos theta cos 0 say cos 0 plus I sin 0. Same complex number can be represented by r cos pi twice y plus I sin twice y. Same complex number can be represented by cos 4 pi plus I sin 4 pi. So on. So when we call r is the modulus of z, theta is the argument of z. So theta takes values 0, twice pi, 4 pi for the same complex number z. Now what does it mean? Argument of a complex number is infinite. When we take argument between values of theta between minus pi plus pi, in this one lies between minus pi and plus pi, may be equal to pi, then we call that argument is called principal argument. Principal argument of z. This value is unique. So when we talk about argument of a z, in most cases we call principal argument actually, because we have infinite values of argument. Suppose theta is alpha k argument of z, then when we take alpha plus twice pi or minus 1, then again you will get the argument. When we take alpha plus 4 pi, same complex number you will come. Argument will be different, but this is, if we call it principal argument, alpha is a principal argument. If we add or subtract twice pi from alpha, you will get different argument. In this way, you will get infinite argument. So given a complex number, we have infinite argument.